There is a plant outside right now that was alive before dinosaurs existed. Not the species, not the family. The exact same biological design, running the exact same systems, doing the exact same thing it was doing 300 million years ago, when the entire surface of the Earth looked nothing like it does today. Every mass extinction that has ever happened, and there have been 5 of them, 5 separate events that each erased the majority of life on this planet, this plant survived all of them. It did not adapt dramatically. It did not evolve new systems or develop new strategies. It simply continued. While everything around it died and was replaced and died again, this plant kept doing what it had always done. And it is still doing it right now, in forests on every continent except Antarctica, completely unbothered by the fact that it has outlasted nearly everything that has ever lived. You have walked past it. You almost certainly didn't notice.
The plant is called a fern, and the reason it is still here while almost nothing else from its era survived is one of the strangest survival stories in the history of life on Earth. Not because it is powerful, not because it is aggressive, because it figured something out 300 million years ago that most life on Earth still hasn't. Go back to the Carboniferous period. 300 million years ago, the planet is unrecognizable. Oxygen levels in the atmosphere are nearly 50% higher than today. Insects grow to sizes that would not be possible now. Dragonflies with wingspans of 2.5 feet, millipedes 6 feet long. The forests are dense and hot and strange, dominated by massive tree-like plants that no longer exist in any form. Club mosses the height of modern office buildings, giant horsetails crowding the swamps. The air is thick, the competition for light is severe, and the pressure to evolve faster, grow taller, reproduce more efficiently is enormous. Ferns were already there, already doing exactly what ferns do now.
The Carboniferous ended approximately 300 million years ago, in one of the largest extinction events the planet has experienced. The climate shifted. The oxygen-rich atmosphere destabilized. The massive tree ferns and club mosses that had dominated the landscape collapsed. Most of the species that had defined that world vanished. The fern did not vanish. It waited out the collapse in the soil, in the spores, in the biology that was already built for exactly this kind of interruption. And when the collapse was over, it was still there. This is the first thing to understand about ferns. They are not survivors in the way we usually mean that word. A survivor implies something that fought through difficulty. The fern did not fight. It is simply built at a level below the reach of most extinction events. To understand why, you have to understand how a fern actually reproduces, because it is one of the most unusual reproductive strategies in the plant kingdom, and it is the key to everything. Most plants reproduce using seeds. A seed is a self-contained unit, embryo, food supply, protective coat, designed to be dispersed, to survive transit, to wait in the soil until conditions are right, and then germinate. Seeds are sophisticated. Seeds are an evolutionary advancement. Seeds came after ferns.
Ferns do not use seeds. They use spores. A fern spore is one single cell. No food supply, no protective embryo, just a cell wall and genetic material. It is, compared to a seed, almost nothing. And it is released in quantities that make seeds look conservative. A single mature fern frond can release millions of spores into the air in a single season. They are so light, they can be carried into the upper atmosphere and travel thousands of miles before landing. They have been found in air samples collected over the open ocean, hundreds of miles from the nearest landmass. They land on bare rock, on volcanic ash fields, on the stripped soil left after a wildfire or a flood, on surfaces where nothing else is growing and nothing else could grow yet. And this is the second thing to understand about ferns. They are not competing for the places other plants want. They are specifically adapted to the places nothing else can use yet. Botanists have a term for this. They call ferns gap colonizers. After any large-scale disturbance, a volcanic eruption, a hurricane, a fire, ferns are typically among the first complex plants to reappear. Not because they are the strongest, because they are built for the moment after catastrophe, when everything else is gone, and the ground is bare, and the light is unobstructed, and there is nothing to compete with.
Mount St. Helens erupted in 1980. The blast zone covered 230 square miles. The heat was sufficient to strip the landscape completely. No soil structure, no seed bank, no organic material. Researchers documenting the recovery found ferns establishing themselves in the blast zone within 2 years, on surfaces that were essentially sterile rock and volcanic ash, before most other plant species had begun to return at all. This is a pattern that has repeated across the geological record. The Chicxulub impact 66 million years ago, the asteroid that ended the dinosaurs, produced a global winter effect that killed an estimated 75% of all species on Earth. The fossil record shows a near complete collapse of plant life in the aftermath, a layer in the geological record so sparse it is called the fern spike. Because what the fossil record shows coming back first, in the years immediately following the impact, before the forests recovered, before flowering plants re-established themselves, is ferns. The same spores, the same biology, the same strategy, moving into bare ground while everything else was still gone.
But the fern story does not end with survival. The part that researchers find genuinely difficult to explain is what happened next. After every catastrophe, after every recovery, after every period of reestablishment, the ferns did not get replaced. Other plants came back and grew around them and above them and developed more sophisticated systems and expanded into every available ecological niche. And the ferns just stayed right there, still doing what they had always done. Today, there are approximately 10,500 known species of ferns, more than the number of bird species on Earth, distributed across every ecosystem on every continent that supports plant life. Tropical rainforests, temperate woodlands, Arctic tundra margins, volcanic islands, cliff faces, the forest floor under dense canopy where almost nothing else can photosynthesize efficiently. The reason ferns can grow in deep shade when most plants cannot comes down to something specific in their biology. Ferns are extraordinarily efficient at capturing diffuse, low-intensity light. Their fronds, the large divided leaves, are structurally optimized to intercept light coming from multiple angles simultaneously. In a closed canopy forest, where the light filtering through to the floor is a fraction of what reaches the canopy, most plants cannot generate enough energy to survive. Ferns can. They found a way to occupy the space other plants abandoned. There is a fern growing in parts of Southeast Asia called azolla that paleobotanists believe may have directly altered the climate of the entire planet. Approximately 49 million years ago, the Arctic Ocean was a warm, enclosed body of water. Azolla, a small floating fern, began growing on its surface. It grew with such density and at such scale that the layer of fern coverage eventually blocked light to the water beneath, collapsing the aquatic ecosystems below it. When the ferns died, they sank. And they kept sinking, removing carbon from the atmosphere in quantities sufficient, researchers have calculated, to contribute to a significant global cooling event. A plant the size of a thumbnail, floating on the surface of an ancient ocean,
may have helped trigger the cooling period that eventually led to the ice ages. The Azola event is still debated. The mechanism is accepted. The scale is what researchers continue to refine. But the basic conclusion, that a fern altered global atmospheric chemistry, is not seriously contested.
Ferns produce a chemical called patoculocide. It is one of the most potent, naturally occurring carcinogens identified in plant biology. Bracken fern, one of the most widespread fern species on Earth, produces it in concentrations high enough to be toxic to livestock, to contaminate water sources, to survive cooking and processing. Bracken covers an estimated 4% of the total land surface of the United Kingdom. It is spreading. It has been spreading for decades. Every conventional method used to control it, cutting, herbicide, grazing pressure, produces temporary suppression. The bracken recovers. It always recovers. Its rhizomes, the underground root structures, can extend several meters below the surface, beyond the reach of most intervention. Cutting the visible fronds does not damage the root system. The plant simply waits and regrows. Botanists who study bracken describe it using language they rarely apply to plants: aggressive, strategic, relentless. One researcher at the University of Sheffield described bracken as behaving less like a plant and more like a slow-motion colonizer, occupying ground, defending it, expanding steadily, resisting removal. Not because it is sentient, because it has had 300 million years to optimize.
Everything that has come after ferns, the seed plants, the flowering plants, the trees, the grasses, every form of complex plant life that now dominates the Earth's surface, developed in a world where ferns already existed, where ferns had already occupied the spaces nobody else wanted, where ferns had already survived every catastrophe the planet had produced up to that point. The dinosaurs came after ferns. The dinosaurs are gone. The flowering plants came after ferns. The ferns are still here. The first humans appeared approximately 300,000 years ago. Ferns were already 299 million years into an unbroken run. They were ancient when the first thing that would eventually become us climbed down from a tree and looked at the ground. The fern in your garden that you keep cutting back is running a system that was already proven before the continents were in their current positions, before the Atlantic Ocean existed, before fish had fully colonized the land. You are 300,000 years old. The fern is not impressed.